Okay, hello Physical Science, this is Mr. B. We're continuing on with the second part of section 3, talking about acceleration. Remember, acceleration is just any change in an object's velocity, so that could be whether the speed changes or slows down or whether the direction changes. So our video today, again, we got introduced last time again to the more specifics of what acceleration actually is, and now we're going to look at how we actually can calculate it. And so how we calculate acceleration for straight line motion, so that's just motion in one direction, is just dividing the change in velocity by the total time. So we'll get an, actually, you know what? We have the equation right there. So the equation that we're getting ready to look at only works when the direction is in straight line motion. So that's when its direction is in one way. That's what straight line motion means. So when direction is changing, we're going to have to use a little bit different formula, but for our purposes, this is going to be the one we're mainly going to look at. So acceleration is the rate at which velocity changes, which we talked about already, and VI is the initial velocity, so what the velocity is at the beginning of the problem that we're trying to figure out. VF is the final velocity, and then T is going to be the total time. So right here, this is our formula right here. Acceleration equals change in velocity over total time. So our change in velocity, we have to take our final minus our initial. That'll tell us how much it changed, and we divide it by the time. And we're going to do a problem here in a second with this equation, so I would definitely write down this last portion of the equation right here, VF minus VI all over T. So this is going to be on your quiz. I'm going to ask you for this equation, so make sure you have that one written down. It says if the velocity increases, the acceleration is therefore positive, and then if the velocity decreases, the acceleration is negative, which we already talked about that with acceleration and deceleration in the last video. And so just to give us an example of what that is actually meaning, it says if you're coasting downhill on a bicycle, your velocity is going to increase, and therefore your acceleration is positive. So that's pretty simple. Then kind of on the next step there is that if you continue coasting onto level ground, because again you're not just going to go straight downhill forever, you're eventually going to hit some level ground, your velocity is therefore going to decrease, and therefore your acceleration is going to be negative. So that again will come into factor when you solve a problem. And then acceleration and velocity are both vector quantities. Remember what a vector is when we drew our arrows, giving us a direction and a magnitude. So to determine a change in velocity, you just subtract one velocity vector from the other. And if the motion is in a straight line, it can be treated the exact same way you do speed, and acceleration is the change in speed divided by the time. So again, this all is a little bit confusing, but it's pretty simple about what it's saying. Again, it's just saying to determine, it just basically is describing what the equation says. You take the final velocity minus the initial velocity. That's how we determine our change in velocity. You subtract one vector from another. So we're just going to do a little sample here. We're going to go step by step here. So here's our problem. It says a ball rolls down a ramp starting from rest. After 2 seconds, its velocity is 6 meters per second. What is the acceleration of the ball? So first thing that we have to do is what information are we given? So we look back at this problem again. I'll read it one more time. A ball rolls down a ramp starting from rest. After 2 seconds, its velocity is 6 meters per second. What is the acceleration of the ball? So the information that we're given first is time, is 2 seconds. So right there, after 2 seconds. So that is our time. Our starting velocity is 0 meters per second. Now the reason why our starting velocity is 0 meters per second, because it says starting from rest. So rest means you're not moving. If you're not moving, your velocity is 0 meters per second. And then the last thing that we're given is our ending velocity, which is 6 meters per second. So this is all of what we know. So we know our time, we know our starting velocity, we know our ending velocity. So then our next step is, what unknown are we trying to calculate? And then what formula contains the given quantities and the unknown? So we're trying to figure out what acceleration is, and then the formula that we need to use is right here, the only one we've been given. Acceleration equals our final velocity minus our initial velocity all over time. And so now we're just going to replace our variables. So we have 6 meters per second minus 0 meters per second all over 2, and that's going to give us 3 meters per second squared down the ramp. So that is how we calculate the acceleration. Again, that's a pretty simple example, but again, I think it does the trick. And then last step, is your answer reasonable? And yes, it is reasonable because, again, the ramp is not very steep, which there's no way for you to really know that, but the acceleration of 3 meters per second squared does seem reasonable. And so for a bonus point for your quiz, if you could solve this problem, I'm not going to give you a place to write this, but if you write the answer to this question and just right below your name on your quiz, then I will give you a bonus point, or maybe even 2 bonus points depending on how many people have the correct answer. So don't share this information, because if everyone has this answer written down, then I'm not gonna award any bonus points. So bonus point for whoever can solve: a car traveling at 10 meters per second starts to decelerate steadily. It comes to a complete stop in 20 seconds. What is its acceleration? So again, solve that problem, write the answer below your name, and you'll get a couple bonus points. And again, I'll decide how many once I actually see all the quizzes. So that is actually going to be it for this video. Let me know if you have any questions.